This is Advanced Conductor Modeling of New Electromagnetism V5. This is the 10th video of the New Electromagnetism V5 series. New Electromagnetism is the 4th book of Ethereal Mechanics. This video is EM0410. Patreon members are seeing this tonight, which is 18th of August 2024, and this will be made public on YouTube on 12 September 2024 at 9 p.m. So we're going to give an update on the electrogravity experiment. Then we're going to get into the new electromagnetism V5 advanced conductor model, which is more advanced than the new electromagnetism V3 conductor model. And then we'll show some physics 2 software considerations and demonstration using the advanced conductor model. So the electrogravity experimental results were earth-shaking. Mega rabbit hole material. Okay, my Patreon members have already seen these results. YouTube folks should have seen it most recently. This should be the first video after seeing those results. Okay, ultimately, it is going to be disruptive a little bit to new electromagnetism V5. And so I made a poll of the upper tiers of Patreon, which would be the bridge officers and first officers. And you can read this on your own. These are my thoughts about going forward. Basically, because electrogravity is kind of a niche thing and not many people are really interested in it, even though it's going to be the bread and butter. It is going to be the thing that's going to make all the changes. The cosmology stuff, which I really want to get to, which is all done. I don't have to do any more work on it. All the simulations are pretty done. I just got to turn everything into video form. That should resonate more with the average person and might help bring more people in as far as Patreon support so I can do this full time. Okay, and so most of the bridge officers either said, I'm okay with any course of action, or chose to pick my side on this. So that's the way we're going to go. So what we have going on with the paper release, the 5.0 paper, which has already been released to the patronage, first class and above, is not going to be made public. Instead, an updated version, which has some typo fixes and some other additional material, the 5.1 paper, will be released first to Patreon members and then made public to everybody else with a big TBD. Then we're going to do is go through and do all the cosmology stuff. And then later, maybe early 2025, we're going to come back and reconcile all the EGX results and make an update to the paper. I have done some work on the EGX results, and I think I know exactly where they're coming from. So I think it's not going to be as disruptive to new electromagnetism V5 as I'd originally thought. I think everything will reconcile actually much better, but we'll see that when we get to it. So here's our immediate short-term path forward. The dates on the left are the YouTube premiere dates. These are Thursdays at 9 p.m. The dates on the right are the Patreon release dates. These are Sunday evenings. And this line here means that all this stuff has already been released to Patreon members. This is what's being released tonight to Patreon members, and then next week and blah, blah, blah. Now, I've had some trouble getting started with all of this. Mental mind block. I've had to go off and do other things to get my mind off it, like watch YouTube videos or clean the house or something, because I've had trouble with creative block, just writer's block, getting these videos done. So I'm hoping I can catch up and get both of these done in one weekend, which is next weekend. If not, we'll let the set schedule slip. So these schedules I post are notional. They're bound to slip, but I've tried my hardest to get these dates out. Eisenhower said, planning is worthless, but it's critical. And that's a very important concept. So I do my best to come up with a plan and stick to it, but stuff always comes up. Okay, so the 5.1 paper is going to be released on Sunday, 25 August 2024 to the Patreon. I'm going to release it to Passenger and above because it's just a few typos and a couple of extra small pieces of information that I think we've already covered in the videos. So there's really no new releases other than an updated paper. And then the updated 5.1 paper will be released 1 October 2024. Now this could slip, okay, just letting you know in advance. And then after we're done with all the cosmology stuff, then we'll come back and complete the electrogravity and the other experiments for new electromagnetism V5 and complete the updated paper. So with this instead, before this is the punch list, these were in yellow. I've changed them to light green, and the reason why is these do get the correct answer, so they should be represented as green, except that these things violate more of the laws of acquisition than these guys do. These violate them, but these are more egregious. So I set them as light green, which means, yeah, they do get the right answer, but they're weak. Okay, and now here is the addition of the Coriolis charge motion, Centripetal charge motion, and the Venturi charge motion in the punch list. And because of the EGX experiment, these are yellow, which means that this is kind of our TBD. More work needs to be done on this. Okay, so let's get into the advanced conductor modeling with a G, not a D. Now, just for the confusion, this is chapter 5.1 of the 5.1 paper. So it's just coincidence that the numbers are the same. So the two major modeling forms that we have are the filamentary modeling form, which is highly improved for new electromagnetism V5, and then the solid conductor modeling form. Now there is one more. We have a fantasy. So I have a method for developing results for conductors that gives me the resolution and precision of solid wire modeling and the speed of filamentary modeling. And we're going to talk more about it a little bit later in case that's confusing for you right now. The most important thing for all of these wire modelings, they're all use the same fragmentary forms of new electromagnetism V5. That was one of the major improvements here, is to get these all to use the same fragmentary models that were derived in the paper. So let's start with the filamentary, which has been improved for new electromagnetism V5. Okay, this is the fastest and easiest method of developing results. It usually, for wire-to-wire effects, only requires a 2-level for loop. Okay, the new electromagnetism is more accurate than any previous techniques that we've used because the wire thickness and the material are considered, allowing the modeling effects that are affected by the thickness of the material, which include resistance, Venturi, Centripetal, etc. Okay, and basically the way the filamentary wire model works is you break up a loop of wire into little short segments that we're going to call fragments. They are differential lengths. And you model it as if all of the current passes through the center of the fragment. Okay, we break up filaments into fragments. That's the lingo. Okay, but because we are using the material and the diameter or the cross-sectional area, we develop the variables for QSPM and QTPM, which allow the fragmentary models to account for wire diameter and wire material, which was not available for previous versions of new electromagnetism. And what these variables stand for, this is the charge, a mobile carrier charge of the source per unit meter. This is the mobile carrier charge of the target per unit meter. Okay, and we discussed that before, so I'm not introducing this for the first time here. Okay, but the limitations of the filamentary model is that the accuracy degrades when the distance between the source and target fragments is less than 10 times the radius of the wire. Okay, and do not use for self-inductance problems. I'm using the symbol to represent self-inductance here. Because you will result in a singularity, because in self-inductance, the source and the target have to be the same piece of wire, and if you do that, the distance goes to 0, and that's where you get your singularity. Okay, so there are limitations with the filamentary. You just have to be careful how you use it. But most of the time, it's great for like 99% of the things you're going to do in an experiment. And like we use it for pretty much everything right now. For solid conductor modeling, we break up the wire into very small chunks. Okay, instead of using DL and then current and then area, we use DL, D current, D area. So we're using very tiny little chunks over the volume of the wire. Okay, in the case of flat wire, like you see here, these are like we break it up into little rectangular chunks instead. So you can use whatever chunking style you want to break up your wire into smaller bits. Now the beauty of this is it allows you to see how each chunk reacts to the effects of all the other chunks. And here you can see we have more of an effect at the body of this due to these other coils that are lined up here. And so the colors show, the different effects the color shows how the different parts are affected, which ones couple more energy. And so this is very eye-opening compared to anything else that's out there. Okay, the other beauty of this is we use the same fragmentary models as the filamentary model. Of course, we're using DA, DL, and DI respectively. There's no limitations of this modeling technique that I'm aware of. However, there are drawbacks. It's very difficult to produce results analytically because it's very complex. Except for some trivial examples, of course. So computers are going to be the way that this is going to be utilized, and it is computationally expensive. 6th level, 4 loops are required, or what we're going to do when we get to this, we're going to be using a GPU. So the existing software that we have right now, or the future software, the existing is the graduate thesis software written in C++, which was written in 2007. It allows high precision printed circuit board trace inductance modeling. It also includes the effect of traces next to copper plane or sandwiched between 2 copper planes. I'll show you how that works in a moment. And we're using a method of images. For the future, probably sometime in 2025, we're going to be producing Physics 3. This will be high frequency printed circuit board analysis using retarded time techniques. And other than the old one, which only did low frequency inductance, we're going to do the whole 9 yards. We're actually going to use new electromagnetism V5 to model signal passage through conductors, waveguides, whatever. Okay, so this is going to be a big product that we're going to produce. I don't know if I'm going to make it public to the patronage. It depends. If by this time we get, thousands of Patreon members that I can do this full time, then I will certainly release it to the engineer and above Patreons as far as the tool set goes. If not, we may just turn this into a for-profit product after it's been demonstrated. I don't know. We'll see what happens when we get there, but this is definitely a product that we're going to be starting development in 2025. Okay, the final technique that we're going to discuss is the fantasy technique. It allows us to obtain the accuracy of solid wire modeling at the speed of filamentary modeling. It's the best of both worlds, but it does have limitations, and still I'm mapping that out. Okay, this technique is not being included in the NVV5 paper. It will be released as a separate supplement publication after I get it finally mapped out and get all the wherefores you're supposed to use it and not use it and yada, 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 yada. But essentially it makes an analytical solutions a snap for things that would have been very complicated. It is so exciting. It is really supercharging our ability to move forward. But as the name implies, it's based on complete fantasy. And when we release how it works, you're going to say, yeah, that's complete fantasy. How it works, I don't know, but it does work. Kind of like quantum mechanics. Nobody knows how, but it works, right? Okay, the last thing we're going to talk about before we show the physics software is the method of images. Okay, and the reason why this is important is because NEV5 has reduced everything to line of sight models, basically optical models. And with optical models, it's much easier to model the effects of other objects on your experiment, objects like composed of conductive materials or ferromagnetic materials or diamagnetic materials, yada, yada, yada. And for the example I show here is from the graduate thesis. Here you have an inductor shape that is suspended over a ground plane, and the way you model the ground plane is a mirror image of the conductor. So the conductor sees a mirror image of itself, just like it was a mirror. And that's how you model a conductive plane to get accurate results of inductors that are laminated next to a ground plane or a conductive plane. And the results are fantastic. Okay. Now, the MOI, the method of images, is going to be included as a later release because there is a lot more work to be done on it, and it's going to be a full paper unto itself, along with Physics 2 simulations on how it works. And even if we get there, it is going to have Physics 3 simulations in there as well. Okay, in the next video, where we're going to talk about model of magnets, we're going to show a little bit more of the model of images with regard to paramagnetic and ferromagnetic materials. Okay, the graduate thesis shows how to use the method of images for conductive planes. And for Coulomb's law, they have textbooks use the method of images for Coulomb's law, so there's where you can find that. In the example shown here, our inductors are sandwiched between two ground planes. And just like if you're between two mirrors, you see infinite images of yourself. And what the original graduate thesis software did is added up reflection after reflection after reflection after reflection. And when you get to a certain number of reflections, it converges to the perfect answer. It's a thing of beauty. So that's all shown in the graduate thesis. So we actually have to add the method of images into the punch list because classical theory only reduces Coulomb's model to an optical solution. So therefore, they do have a method of images, and that is the same method of images we use for all of the new electromagnetism. We don't have it in the paper because it's already done. No reason to write it down again when it's already written down. Where classical theory does not have is with magnetism and induction, because they do not have these models reduced to an optical solution like we do. So they cannot and they do not have method of images. They do know of these effects and they do model these effects. Okay, but they have not reduced them to a simple optical solution like we have. Okay, to put a fine point on that. Okay, I did not have them for the first versions of new electromagnetism because I had not gotten to the point where they were even important to me yet at that time. It wasn't until new electromagnetism V3 that I started discovering the ability to use the method of images for first and second order effects, and those carry over into new electromagnetism V5 with some improvements because we have a much better model of magnetism. So this guy is improved over the previous version here. The second order effects are going to be the same as they were for new electromagnetism V3 and V5 because new induction has not changed. Okay, the important part of the method of images is they use the same new electromagnetism V5 fragmentary models. So all of the techniques that we have use the same fragmentary models that have been developed over the course of this paper. Now, it's kind of all confused here, so what I've done is I've consolidated them here. I also realized that I do need a Venturi inertial force, a fragment-to-fragment version. That's on my list to do for the probably going to hold that off until the 5.2 paper. It's not hard to derive. You just do the same thing with this you did with this, so it's not that big a deal. Now, because of the electrogravity experimental results, okay, these guys right here are affected. Okay, but because they have QSPM in their denominator, this shows that they're extremely tiny effects. They're 10 to the 4 are smaller than these effects that we normally would use. So it's not going to affect most of what you're doing. Okay, so we're going to put this is our TBD section. Okay, and these will be reconciled with the 5.2 paper. They may change slightly, but there also will be additional effects that have never been seen before. I'm pretty sure of that right now. Okay. But instead of you going all crazy trying to reconcile, because not only do you have to apply all the new electromagnetism V5 models for all the different, you have to figure out what is the Coriolis acceleration, what is the Venturi acceleration, what is all of this stuff. Okay, and so that's a lot of work. Okay, but luckily we can let the Physics 2 software handle it all for you. Now, right now the Physics 2 software is only available. Well, it has not been made available yet. When it is made available, it'll be available to the engineer and above Patreon classes. I don't expect to release it to anybody other than that, because this is a very interesting proprietary software I am still using it to explore effects. Okay, this is still very proprietary software. It's being used to reconcile and explore all the effects, including the electrogravitic results. And so right now, I'm keeping this close to my chest, as it were. Okay, but the Physics 2 software is based on the idea of a rotating reference frame, like the Roundup, because that's the way that you bring the Coriolis and the centripetal effects to the forefront, is with rotating reference frames. Okay, so we can represent a Physics 2. This F2 is the software construct for the Physics 2 frame. It is basically a coordinate system where its coordinate system is separate from the global coordinates. Right now they're shown aligned, but they don't need to be. You can have a separate face coordinates for this reference frame. And these all should be lowercase to show that they're a different reference frame than the global. All the global stuff is capital. All the local reference frame in the Physics 2 software are lowercase. Okay, not only can you have a different orientation, which I call face coordinates, it's the face of the reference plane, which way the face is pointing, as it were. You can also have angular offsets. Now, all of these, theta, omega, and alpha, are part of the reference frame, and they will rotate all about the z-axis. I only allow rotation around one axis to make everything simple, because if you want to extend this to another axis, you would just mount another reference frame inside of this, and you can twist the reference frame of that any which way you want. So you can embed a reference frame, a rotating reference frame inside a rotating reference frame inside a rotating reference. And we'll give you an example of that with the Physics 2 software. Also, this reference frame can have a position, velocity, and acceleration of itself relative to the global reference frame. So the Physics 2 software will take care of computing all of the Coriolis, centripetal, all of that for however many compounded reference frames you have. And it'll take care of making sure, because at the global reference frame, we're using a static ether model. For this Physics 2, the ether is static. Okay, so now I'm going to show you examples. So we can nest a reference frame inside of a reference frame, and then I can attach an object like a magnet to that. And then I can put another reference frame with its own magnet spinning whatever direction I want. Now let me show you the simulation that's now been running for about 4 hours. Okay, so here are two loops of wire with current in them. And they're counter-rotating, but they're also rotating around this axis. The yellow, red, cyan, purple, and there should be other yellow here. There should be another color. These are the coordinate axes. Yellow is the positive y-axis. Red is the positive x-axis. Cyan is the positive z-axis. This is the origin right here. Okay, so that is an example of the Physics 2 software running a simulation of loops, spinning around loops, inducing effects onto this D-shaped loop here. The reason why we put this cutout here is because we have to typically put a motor axis in there. So we want to simulate the effects as the wire has to deviate around a space for an axis. In Physics 2, there are 4 main components. You have a frame, a filament, a charge, and an impulse. Impulse are the combined effects of the Venturi and centripetal effects of current going around the corners of filaments. Everything else, from magnets to sensor planes to everything else that we have in the Physics 2 software, is derived from these 4. And in fact, like I said, you can nest however you want to your heart's content. Okay, the next video is the Patreon members will see is NEV5 model of magnets. There'll be some more Physics 2 demos in there. And there'll be a little more of a demonstration of the method of images in relation to paramagnetic and diamagnetic materials. At this same weekend, okay, which is, I believe, is the 25th, the 5.1 paper will be released to the first class and above. After that will be the Hall effect. And then we'll have the conclusion and the look ahead. Now, after this, I'm going to update my website so that all the links are fresh for New Electromagnetism V5. I've been trying to get to it, but I'm going to have to do it here because that's when all of this will be done and it'll all be able to be posted there. And I just realized during the making of this video that the latex experiment has only been released to Patreon members, so I will be including a latex experiment release somewhere in here for worldwide release. Okay, this is the main YouTube site for ethereal mechanics. Everything is posted here. Everything is in its own playlist, whether it is the Pretonics standard model, Electrogravity Series, Transvariant Series. We don't have anything for Ethonics, Pretonics yet. Fortrix Algebra, Rules of Acquisition. Well, we have to post for Rules of Acquisition. New Electromagnetism V5, and Cosmology will be the next set. This is the repository. It's not up to date yet. It'll be up to date when we complete the New Electromagnetism V5 series. This will be fleshed out with all the videos. So you can watch them in order by clicking here rather than trying to find them on YouTube. If you want to get the ethereal mechanics stuff, that's here. This is the blog site. Shout out to Sebastian for hosting this. I hope if we can get enough Patreon members that I can do this full time. I'll have more time to spend here. Right now, every moment of every day is spent getting this stuff done, the experiments, the papers, the video production. I'm sorry, and my job at work is getting more intense and is starting to steal hours from my ethereal mechanics hours. So it's just the nature of the beast. This is the Patreon site. $5 a month, you get to see all the stuff. You see how the Patreon members see stuff sometimes as early as a year before it's released. And they have access to other videos which I haven't released yet. So if you want to see all that stuff, it's $5 a month. It isn't going to break you. No more voodoo physics. Thank you very much.